Hi there, my name is Sudhir Bandaru. I'm the founder and CEO of Hivel. Before this, I've been a software engineer turned CTO. I would like to talk about engineering productivity and dive into the product demo. Engineering leaders like Mark Zuckerberg, Sundar are worried about productivity. And companies like LinkedIn are taking measures to improve developer productivity. And likewise, we also can see how Uber is measuring engineering productivity. While this is happening across the globe, we wanted to understand that driving engineering excellence that maps to the business outcomes has been critical than ever before. The reason being, companies are trying to move towards profitability, and it can only be achieved when engineering teams are efficient, which is a DevOps research assessment, where the research has been done across 30,000 plus companies by Google and came up with the metrics that would help understand the health of an engineering team. Likewise, we also have a lot of research around space metrics. These are the things that we will dive into the product right out of the box at Hivel. At Hivel, we bring data from tools that developers already use, like your GitHub, GitLab, Jira, and turn them into dashboards and actionable insights. Here, let's dive into some of the metrics, what we have seen around DORA metrics and space. This is something that talks about speed. Speed is looked in terms of cycle time. Cycle time is the time from the first commit to PR merge. While this is the speed, we wanted to understand the leading indicators of metrics that contribute to the cycle time. Here we can see the coding time that talks about what is the time it takes from the first commit to PR open. Once an engineer writes his or her code, you wanted to understand how long it takes for the review process to happen. Review time is a time from the PR open to the final review. And moving on to the merge time, this is the one that talks about once the PR is approved, how long it takes it to be merged. Collectively, these are the metrics helping us understand what are the bottlenecks in the speed for the engineering teams. And then we have deployment frequency, which talks about the number of times number of pull requests are merged to master or any of your release branches in a given period of time. Collectively, you are able to say how fast a team can move from the first commit to PR merge and see how many deployments are you able to do in a given period of time. Quality talks about change failure rate, which is one of the very critical DORA metric. Change failure rate is the number of pull requests that are marked as hotfix or any such configuration that your teams may be following. This helps us track how many production issues are happening in a given team and what are the leading indicators to avoid change failure rate or minimize change failure rate. We wanted to understand how many of the pull requests are being reviewed and how many are not being reviewed. Likewise, we also wanted to understand how many of these are flashy in nature. We mark a review process as flashy when any pull request greater than 200 lines of code has been reviewed within 5 minutes. We wanted the review process to be thorough and flag it when it's not thorough. Put is something that talks about the number of commits, PRs open, PRs merge, and a lot of other metrics. Similarly, you wanted to understand what's happening on the active days. Active days talks about how many days in a week an engineer is active. When we say active, it's any sort of Git activity. It could be a commit, PR open, PR review, or merge. This helps teams understand who are the teams that are burning out, working for more than 5 days a week, who are the teams that are stuck for under 1 day or minimal activity, and helps you to optimize the resources effectively based on this data. While you have all this data, we can also compare the teams. If you are using teams which are using Copilot and some of the teams that are not using Copilot, you'll be able to click on the compare button and see the difference in metrics across these teams. Imagine you're trying to make a decision about the impact of AI tools like Copilot on your team. Here you can compare these two teams, the teams that are using Copilot, the engineers, or teams that's not using Copilot, and understand where are the benefits of using Copilot. Here you can see, are the commits going up, commits going down, what is the quality, what is the speed, are the engineers able to increase their speed when they are using Copilot versus not using Copilot, right? All of this helps you to understand and communicate the impact of engineering efficiency in a very objective manner. Now, let's say you have seen the trends of the team over the last couple of months and you would like to set a target to improve the speed of the team. Here you can come say, the current cycle time is over 2 days, and I would like to try to bring the target to under 2 days. Let's set this as a goal and track the performance of the teams and see how the teams are doing in terms of the set targets. You can click on these and see which are the teams that are on track, off track, using a simple color combination of green, amber, red. This would allow you to understand what's happening with the engineering team. How can you coach and help and offer support to the respective teams that are struggling to meet the targets? Now let's move into some of the project management screens. This is the one that's pulled from Jira that shows you how the teams have been doing for the last 5 sprints. What is the velocity of the team? If the teams are using tickets and not story points, you can go by tickets. If the teams are using story points and you want to track this by story points, you can see the same way. This single screen that is showing the data across 5 sprints tells me there's a huge workload for this week of sprint 25, and also helps me understand that it happened because there's a lot of bugs that happened compared to the previous sprint, and probably engineers have overworked on that sprint. If I wanted to dig deeper and understand what's happening in this particular team, what are the bugs, I click on this and I get to the details. I can see all the Jira data. I can see all the commits and the PR activity against each of these categories, what I have selected on the top. In this screen, I'm able to correlate the data between Jira and the Git activity. This shows me there is 3 story points, which took around 12 days with 45 commits. Likewise, there is another one with Akshay, which took 8 story points and 14 days and 26 commits and all the PR activity. Equally, there is a 2 story pointer that took over 1 month. This kind of data helps engineering leaders, team leads understand where are the engineers getting stuck, how can we recalibrate on the story points, how can we be better at estimates and offer immediate help during the sprint. Moving on, we are able to understand where the investment is going in terms of the projects. Are we investing on the right projects? We have a lot of epics and we can understand if which are the epics that are taking most of the time. This single graph can tell you if the engineering teams are focused on key projects or they're spread too thin across multiple projects. This screen shows the amount of effort that is going across multiple products and how you're able to categorize what kind of effort it is, what kind of investment is it. Are the engineers working on the roadmap items? Are the engineers working on tech debt? Are the customer support requests? Everything can be classified and seen very easily across multiple boards across a period of time. Likewise, we can also understand what is happening in the team around allocation. Allocation screen allows you to get a holistic visibility into where your engineering efforts are being invested. If you wanted to understand what's happening with tech debt, this screen quickly shows me that the tech debt has been going down in September versus October. Now, the team leads are empowered with a lot more data to help them improve productivity overall. This screen allows me to see the process, understand where the bottlenecks are. If you see a spike in the review time, you can come here and see the reason for the spike. Click on this, and you see there is an average of 11 hours is the review time across 141 PRs. If I wanted to understand what are those PRs, and I can click here and see if there is a review process that is taking over 11 days or 9 days. This will help me to understand who are the blockers, where is the bottlenecks. Likewise, when engineering teams have seen some of this data, and if it seems to be an outlier, you can exclude this particular data from your reports to keep the data clean, to get a realistic picture of your process and metrics across. Activity is a very powerful screen that helps you and the team leads understand the efforts that are being spent across the team on an everyday basis. This captures all the Git activity that is happening across the team, where you can easily filter by the type of activity, which engineers are reviewing the code, which engineers are committing a lot of code, and the size of the bubble represents the size of the activity. For example, you see this is a smaller commit with 64 lines added, whereas this one is a bigger commit with 400 lines added. I wanted to understand what is this bigger commit and click here and see what's the code. Activity screen helps the team leads understand the work distribution that's happening across the team members in a team. This captures all the Git activity across commits, PR open, PR reviewed, PR merges, and any activity that is happening over the weekend. You can see that there is an activity on over the weekend. You can also change some of these things. Who are you burning out? Who are the engineers burning out? Who are the engineers who are getting stuck? Where you can redistribute some of the work across these engineers. You can see here in this case, Aaron is loaded with a lot of work, whereas Tina got stuck with a single commit. This helps you to understand and reshuffle some of the work from Aaron to Tina. Pull request screen gives a bird's eye view into what's happening in terms of speed and quality of the team. You can understand the speed at which the teams are able to deploy, which is 2.5 per day. At this rate of 2.5 per day, we are able to see some change failure rate of pull requests. You can see what are those hotfix pull requests and likewise understand how fast the team is able to bounce back when such incidents happen. You will also understand some of these leading indicators to see what are the flashy reviews that are happening, what could be causing some of these. Flashy reviews, like I said, are a minute. These are the ones it's important to surface and understand what's happening with these PRs. Likewise, you can also understand what are the pull requests with over 400 lines of code. Industry standard tells us that it's important to kind of have a PR size to be under 400 lines to minimize the blast radius and the impact in case something goes wrong. And likewise, and also help reviewers review things faster. Coding screen helps us understand three critical metrics of what's happening with the engineers. Every new line of code is going to new work. Every line of code that has been modified but was written in the last 30 days is rework. Any line of code modified but was written prior to 30 days is marked as maintenance. This screen very quickly gives me insights to understand there is a 14% of rework and 25% of maintenance. Or in other way, there is only 60% of the actual effort or the output that was delivered by the team. We can understand the root of the rework. Where is the rework happening? What are the reasons for the changes? Click on any of these things, open the code and open the Jira ticket associated with it to understand how we can minimize rework, which is nothing but a code churn, which would not actually yield any immediate value. Rework happens for either the pushback from the reviewer or bug identified in QA, or the engineer is trying to polish the code, what they have written originally. Maintenance is sometimes a good sign. The engineers are trying to clean up the code while they're trying to add new features. And understanding that the maintenance is being too high, also high maintenance also could be a flag to say this is probably a repository or a project where you can invest in tech debt. There is a complete timeline view that helps you understand what the teams are working on, what are the categories, if it is a roadmap item or if it is a customer success request, and see which are the teams that are on track, in progress, cancelled, delayed, or not yet started. This is a quick bird's eye view into understanding where you can help the team reprioritize the projects and assign more resources accordingly. Thank you so much for your time and reach out to Sudhir at Hivel.ai for any questions.